So kind of moving into it, kind of working with the water phantom in our development, we kind of look to see, obviously what the objectives are. You want to be able to do your acceptance and your commissioning of your LINAC, so you're checking your systems against the manufacturer's stated specs. You're doing your annual QA, possibly monthly, with the 1D Phantom or 3D Phantom, and you're doing those TG142 tests for AAPM or whatever your specific protocol is, and also those periodic checks of beam quality as they're needed, say after a preventative maintenance stop by your LINAC manufacturer or a repair, things like that. So those are your kind of your objectives for a water phantom. And of course, going from there, what makes a good water phantom? You obviously want highly accurate and repeatable positions of the system and the armature and the robot movements, so you get good repeatable ion chamber movement and good results. And that it's something to produce high quality raw measurements. You don't want to have to do a lot of post scan processing, and that's one of our strong suits, is the accuracy of our system. Really kind of minimizes those post scan processing time. You want that reliable hardware year after year. It's a very robust system. Again, since it's best case scenario, you're only going to use it for your annuals once a year. You want something that you can go to and have a reliable operation when you do need it. You want that easy setup, since again, it might only be used on an annual basis. So you don't want to have to kind of quote unquote relearn the software. You want to be able to kind of jump right in and start scanning. And I think with our software, as I'll show you, we've made it user friendly, and I don't want to say simple, because it does do everything you need to do for getting your beam data, but it's very easy to kind of navigate and work through. So you don't necessarily have to kind of relearn it time and time again. And you want that flexibility and compatibility. You're going to be wanting to use different detectors, be it the included ion chambers that we offer or provide with our system, our X-ray and A28 detectors or ion chambers, the 0.125 cc scanning chambers, but also things like stereotactic diodes. We've got a couple of different ones of those. We've got a scanning scintillator, the first commercially available scintillation detector for very small fields. That's a 1 millimeter by 1 millimeter detector. So you can do very small fields for that as well, utilizing the W2 scintillator, as we call it. And you want to be able to import it into various treatment planning systems. And we do a whole host of different planning systems, from the Eclipse to Pinnacle to Monaco, RayStation, CyberKnife. So you want to be able to have that flexibility depending on what LINAC components you have in your facility. So, but kind of getting into the system itself, as I kind of mentioned, I'm going to start kind of just touching on some of the hardware specs that we utilize for our water phantom, and then I'll kind of move into the software and show you some of the advantages and some of the ease of use functions there. But basically everything with our system is built to be robust and repeatable. We use a heavy gauge extruded aluminum frame. It maximizes that rigidity. It simplifies the setup, and it maintains that reproducibility very, very tightly for making sure that your scans are very accurate. Everything within the system is repeatable and positional within 0.1 millimeter per axis, so it's a very accurate system, giving you the ability to do sub-millimeter resolution on your scans. It allows for a precise and quick 3-point leveling. We do use a more of a manual system for leveling, but I'll kind of touch on that a little bit. We've got a nice feature set that allows you to do that very quickly and not have to kind of revisit things if you do once you do get it set up. And then each individual system, even before they go out the door, they're given a burn-in time with the motors to make sure that everything is functioning correctly. But then we also run it through a industrial coordinate system for measurement to verify that accuracy and performance, those 0.1 millimeter accuracies across the board. Some of the other components within the system, The water tank and the frame are mechanically secured to each other, so that ensures that that long-term integrity and accuracy. We have an advanced suction drain, which when you're done scanning, you want to be able to get that water out of the tank, and we've got a moat system. So, even if there is a little residual water in the tank, it's not sitting. The armature of the scanning system is not sitting in water, so you can rest assured that you can don't have to worry about any kind of oxidation or any kind of mineralization on the armature, because it does get the water out. We do recommend using either deionized water or um, distilled water, but obviously, or water with a conditioner in it. But sometimes that's not the easiest to do. So if you need to drain that water, we'll get that out and not have it sitting in any residual water. And then we have that fully integrated lift and reservoir cart with very precision positioning platform. We do also have an optional lift cart that's the cart only, does not have the reservoir, so that that option is available as well, depending on what your needs are. And going on about that, the cart, we also on the lift platform, we've got a positioning platform that gives you a very precise setup. So once you kind of get your course adjustment under the gantry, under the collimator, then you have a fine adjustment in the X and Y position, as well as rotational. So you can kind of tighten down and kind of accurately adjust that in very, very small increments. And then we also have rotational adjustments that lock into place at the 45 and 90 positions for those diagonal scans. Also redesigned the tank a couple years ago for Halcyon and Ethos compatibility. It's got a little bit lower profile. It's a little more compact design. And then, not only did we shrink it down, but we also gave it improved rigidity because of that. So it's like I said, it's all about accuracy. Is you want to make sure that your data is precise and can be done quickly. So some other features, we've got an intuitive wireless pendant. You can see there, it's got a full readout on it for the positional spacing of the position of the detector. You can set your origin. You can move it in any direction at various speeds as well. It gives you, it helps simplify the setup and the system configuration when you're setting up your water phantom. Again, that onboard display always shows that probe position wherever it is in space in the water phantom. Probe speeds can be adjusted from 0.1 millimeter to slow speed to fast speed for just kind of moving around the phantom. There's a nice thing too is we got an actual disable bias switch on the pendant. So sometimes you walk out of the room to start something and you realize that you need to go back in and make an adjustment, and you might leave the bias on. Saves you trips in and out of the bunker, having that bias switch at the pendant. And then we also have the ability to have either wired or wireless connectivity to the PC from the Water Phantom. We include that with the system. It's a Zigbee receiver and transmitter system. So if you want to have a wireless from the water fan to the wall of the bunker, so you don't have all those cables to be tripping over, you can set that up as well. So it gives you that versatility and convenience very easily. One thing that Standard Imaging is known for, I'm sure you're probably very familiar with Standard Imaging as far as our electrometers go. We've got a long experience with electrometers, and that doesn't change at all with the DoseView 3D electrometer. We took that standalone electrometer knowledge that we've had over the years and produced and developed the DoseView 3D electrometer. It's a charge digitizing electrometer, so you get that high-speed acquisition for your fast scanning. You get 10 femtocoulomb resolution, so it's a very fine resolution as well. We've got the dual polarity bias, so you can either do positive or negative bias voltages. And then you can also do independent bias if for some reason or for whatever, you might be using an ion chamber for the reference, but a diode for the field measurements. You can turn off and turn on the independent bias depending on which channel you are using for no bias. So I kind of mentioned, the 3-point leveling and our alignment system. We utilize what we call an alignment water surface alignment jig, and you can see that kind of both in the lower left where you see all the center left, I should say, where you see the water surface alignment jig, and then in that cartoon drawing as well, just kind of showing you alignment. It's like I mentioned, it's we use a 3-point leveling system, and with that alignment jig, it gives you easy visibility for doing your runouts. It's a very quick system, because you have the X on the end, and you've got the crosshairs on the sides, and you can easily see any distortion or level of the water against those crosshairs for easy and quick setup when you're doing your leveling and your runouts. So it's actually a very quick system. We've got a system at the University of Wisconsin Cal Lab, and the gentleman there that does most of the scanning can go from filling the tank to scanning, probably in about 15 minutes. Once the tank is filled, and he can get the alignment set up in about 15 minutes. So it's just as quick, if not quicker, than some of the automatic leveling systems out there. Whereas with the automatic leveling systems, you have to rely on it, but you're still going to do your checks and your runouts after you let the system automatically level. So it's really no quicker than utilizing our innovative detector alignment system. So we've got that jig, like I mentioned. We've got multiple detector holders are included. You'll see there, we've got 6 different ones. That actually, I believe, comes with 9 different ones now that holds a number of different chambers. There's a universal chamber if you want to use, say, a farmer chamber. We've got one specific for our A28, which is the included system, smaller for diodes and for small volume microchambers. We've got the parallel plate ion chambers as well. So if you've got a Marcus or a Roos chamber, those can be used. We try to be with our chamber holder. We try to be vendor neutral, so you can utilize any type of or any company's detectors that you would want. We've also done custom detector holders in the past. So if you have something that's kind of out of scope as far as some of the conventional scanning detectors, we can talk about manufacturing a holder for you as well. And I mentioned and kind of touched on that alignment jig already. Another nice feature for the software is we have we call automatic find beam center, and basically it will, with the beam on, the software will allow you to kind of localize and find that beam center, and if it's off just a little bit, it will tell you how to shift it. It will actually shift it automatically for you to that new origin if the position is not quite square to the center of the beam. So that's a nice automated feature as well. And I kind of just, like I said, I want to touch on, we about a year and a half ago or so, we kind of merged our 1D software into the 3D software. So you've got the functionality of the 3D system that can be incorporated for the 1D system as well. So it's, the software gives you the ability to do those depth curves and depth dose measurements automatically, and it can also do single point measurements too. So it utilizes 2 different sizes. We've got a small tank and a large tank. We've got a 3-point leveling on this system as well. Full function pendant included, and it utilizes either the Max 4000, the Max 4000 Plus, or the Super Max for use with our software automatically integrated into the system. So that's kind of our 1D scanning system for those monthly TG51 and TRS-398 measurements. I kind of mentioned our ion chambers that are included with the system. That's our A28 0.125 cc volume ion chambers. Nice thing about them too, it's a spherical collecting volume. So if you're going in plane or cross plane, there's no adjustments that are necessary. You're getting similar readings in both X and Y directions. The nice thing about our chambers too, they're homogeneous as far as their construction goes. We use conductive plastic C552, So your collector, your guard, and your shell are all made of that. There's no high Z materials in the beam for perturbing the beam. They're all basically water equivalent plastic material. And we've got our ion chambers, anything from our smallest A16, which is a 0.007 cc, up to our larger detectors. Not only our farmer chambers at the 0.6, but also a number of different spherical chambers as well for health physics and environmental measurements. And the nice thing about our chambers too is they are repairable. If for some reason you may drop or break a shell or crack it, pulling it out of a solid phantom, things like that. Sometimes that does happen. They can be repaired. And we've got that proven X-rated quality that we can offer a 5-year warranty on all our ion chambers as well. So now moving into the software, basically, we set it up to be an easy web-based software to use. It's very easy left to right, top to bottom navigation, something you're very similar with or familiar with as far as similar to Windows type navigation. It's fully integrated, like I mentioned, for our DoseView 3D or our DoseView 1D Phantom for scanning. We like to say there's what we call no hidden features. So once you're in the software, you don't have to kind of dig around for things. Everything is kind of at your fingertips. It's a simple three tab system. We've got a setup tab, a measurement tab, and an analyze tab. And really, once you get into any of those, everything is right there for you. So you don't have to do any digging, and it's pretty straightforward. And everything's very intuitive as far as your scan queue setup, your measurement and analysis tools as well. So it's a very quick and easy software to use. So I'm going to kind of jump into the software a little bit and kind of give you a quick run through of what we're kind of looking at. So I'm going to jump out of here. Let me jump into the software. Apologize, I didn't have it quite set, but here's your splash screen. You've got to enter the DoseView 3D, or you can enter the 1D side. I'll enter the 3D side, and then, like I said, it's a very simple interface. You can kind of set your clinics up accordingly. You can add your clinics. You can add your machines. So I've got a clinic, maybe a TrueBeam here with my Clinic 2 demo, and it'll show me what energies I've got. I've got four MV beams here. I got a 6 MV beam on this Linac. So that's basically your clinics and machines. You set up your detectors as well. I've got a number of different standard imaging detectors here set up. You can add them. They don't have to be standard imaging detectors that I mentioned. If you're using PTW ion chambers or other detectors, you can utilize those and add those accordingly as you see fit. Preferences, that's just kind of where you set your time and your month your time and your month formats, depending on your region and what your decimal separators are, whether you're using period or commas, your CSV delimiters, what you use to separate your CSV format, things like that. So that's your preferences. And then going back to the scan queues, very easy to add a scan queue. Just kind of touch on that real quick. You'll see here you've got 4 main categories. You've got general energies, field size, and scan types. And you can see they're also not set, so they'll kind of walk you through. So if I do a test set here, you'll see now that I named it, that's complete. I can choose my energies. I just want to do some 6 MV for this one. My field sizes, maybe do a 20 by 20 and a 10 by 10. You'll see now those all are marked, start marking complete. You can add if you're using asymmetrical fields, if you're using different fields and lengths and widths, you can add those accordingly. You can delete them as needed. I don't do any 12 by 12, so I can easily get rid of that. That's gone. You can also, if you're doing cone based, you can use circular field sizes as well, and that just changes then to the diameter in centimeters. So that's all complete. And then my scan types, here's I can do cross plane, I can do in plane, I can do my depth scans, I can set up diagonals, I can set up half scans in positive and negative in plane and cross plane. So it gives you a full functionality there as far as your alignments as well. So easily enough to pick those cross plane and plane and depth. I want to do depth. I'm just going to do 10 cm today. I'm not going to do any anything off axis. But if I do want to do something off axis, I can add either positive or negative here, and that'll populate up here. But I just want to do 0 today. And then my last one is scan mode, and this gives you the ability for profiles and depth to kind of choose and do different things. I can either choose step or continuous scanning for the DoseView 3D. My zones, I can either choose a single zone, which basically gives me a single resolution all the way across the field, or if I want to do multiple zones, say I want to do a little higher resolution in the shoulder and penumbra region, I can choose that, and now I'm doing 2 in the green area, 2 in the blue area, but I'm doing 1 millimeter resolution in the orange area for that penumbra region. And then you can choose your zones here. You can choose your overscan distances as well, and that goes the same for your depths. I can choose a single zone. If I want to do multiple zones, I can do a little higher resolution in the DMAX region, get a little more information through there. I got my zone start, my zone end. I can choose to go up or down. So I also have a force point at DMAX. So if I've got a scan path that would not necessarily hit a DMAX point, I can force that point to be measured at DMAX, and it will return back to its original path after it does that forced point at DMAX. So that's kind of what we've got for the add queue and the setup to queues. So I'll save that, and you'll see that basically now has the test queue that I just made. Measurement queue is very similar as well, very easy to step through. You've got your different things here. One nice thing about our DoseView is, again, since you're not using it every day, or like I said, best case scenario annually, you've got the ability to use it offline in demo mode, so you can go ahead and click that. And now I'm connected to a simulated water phantom, so I don't have to be connected to the hardware to play around with it. So I can connect that, I can initialize that. That marks as ready, as you can see here. My detectors, I'm going to choose my 828 and maybe my 828-2. So I've got my two 0.125 chambers. For some reason, if you're using a system that you don't want to use a reference chamber, you can choose to not use a reference chamber. Set my electrometer up. I can choose my bias. I want to do maybe 300. I can do that for my field and my reference. I can 0 from here, and you'll see now that turned blue and we're ready to go. Everything is blue and ready. And I can go ahead and pick my queue. So I can load my queue up, and so grab that last one I did. So basically it's telling me I want to check my dose rate settings, make sure those are correct. That's in the hardware here. There's my dose rates there. I can choose those accordingly and set those up. Go back to my queue. I can 0 from here. I can normalize from here. So if I want to go to my depth, I can normalize at 1.5 for my number lock is off. There we go. I can go to that position and I can normalize. So I can close that. You'll see up here, you'll see that it always shows the position as opposed to, as compared to the origin. So now I'm at that 1.5 millimeter depth or centimeter depth for the normalization position. And then I can go ahead and scan. And you'll see here the scan window shows me my active scan, as well as its percentage of completion. And then when that's done, it'll move here. And then you'll see here I've got my 20 by 20 field size and my 10 by 10. When it goes to that point, if you have to change, say, an energy, or you have to change a field size, you'll get a notification window just saying, hey, you need, and an audible ding saying that something needs to be adjusted. So that kind of will take care of that as well. While this is scanning, I'm going to jump into my analyze, and I'm going to just kind of maybe pick a couple scans to load here. Let's see, maybe some couple of 6 MV scans, just kind of to show you. So here I've got my my scans. Nice thing too, I can set some reference. If I have a set of scans I want to choose as my reference, and then I want to compare those. Then you'll be able to do a gamma comparison. Obviously, these aren't my references, are not these scans. I've set those previously, but you'll get not only a gamma graph here showing you your gamma results. You can see here there's a little little distance and percentage failure there, so I got quite a high gamma, but everywhere else it's kind of showing okay. It matches pretty well. But you can also set up and look in your metrics here, showing you not only a visual aid for your gamma, but numerical metrics comparison as well, where my center of my beam is, my edge, my number. So your various different metrics here, your central axis percentage, things like that, flatness symmetry, etc. So you'll be able to compare the non-bolded is what your reference numbers are, and the bold numbers is what your current scan you're looking at and comparing to. So you've got that functionality there for those for viewing and comparing it to a reference. Number of filters we've got the Gaussian and the boxcar smoothing filters. We've got a few different we got ability to point edit, so you can edit points on the curve if need be. We've got a couple different normalization tools. You can center the beam scan if needed. You can do an average symmetric as well. You can mirror it positive to negative or negative to positive. You've got the ability to do a flip if you want. And there's my scan difference. So it's just kind of telling me that now I got to change my my field size. So I can go back to measure. I changed my field size now 20 by 20, so I can go ahead and continue my next group of scans here. And you'll see that each they're color coded too. So each group of scans has a different color. So I've got my my 20 by 20 scans here, my 10 by 10 scans here. If I had additional scans, they'd kind of go in that striped pattern as we go down. But basically, other things we have functionality for. In addition to our scan data, as you see here, we can export the scans in any number of treatment planning systems, like I mentioned. We have the ability to go to Eclipse, to Monaco, Electa's Aqua QA component, Philips Pinnacle, Rayplan, CyberKnife. You can also export into our DoseView. So if you've got DoseView software installed, say on your personal laptop, and you want to do some analysis, you can go ahead and export that. We can export to a CSV as well, a CSV report, PDDs. Then we can also convert those PDDs to TPR tables. So that functionality is all there as well. So those are some of the conventional exports. We also have reporting a couple different ways. We're coming out with our version 3.2, and we added the ability to do an isodose PDF report or a CSV report as well. On the roadmap is some more PDF reporting as well. So that's probably going to be in the next version, which will probably be early next year. You can also, nice thing too, if you've got a legacy system, say an older PTW or IBA water phantom, you can actually import scans from either of those into DoseView, so you can do some analysis and some comparison there as well. Should you change systems accordingly, you'll always be able to kind of look at those legacy scans, if you will. So, but that's kind of, and then you also have your visualization tools here. You can go ahead and, if you wanted to zoom in on a certain section of the beam profile, you can do that. And you can always go back home to that by just clicking on the home button. But you've got the ability to kind of move it around accordingly. Once you click that, you can go ahead and zoom and move out. You can see the different tags as well, where your different points are. So if I'm at here, I'm at 0, I'm at 99.98 of ionization there. You can do for your depths, you can convert those to dose as well very easily. That's all incorporated in the system. So, like I said, it's a very straightforward system, very easy to use, very intuitive as far as the software goes, and the setup, and the scan keys, the measurements, and the analyze. So, but that's kind of just a quick run through and touch on the software. I'm going to kind of jump back into my my PowerPoint here. So basically, I'm going from there, kind of touching again on the water fan, the hardware. Everything is structurally rigid as far as design, the design of the system and the manufacture of the system for that repeatability and accuracy. It's really unparalleled in the industry. Everything is positional precision to 1.1 millimeter per axis. You got a very quick system set up with the water alignment jig and the leveling. The wireless functionality kind of adds to setup ease and time saving. Got the fast acquisition electrometer with those independent biases. It's very intuitive and versatile detector system. Like I said, it comes with a number of detector holders for the various types of detectors you want to use. One thing I didn't mention is those detectors can either be used in a horizontal or a vertical alignment. So if you've got vertical diodes, you can use those in a vertical alignment as well. And then just kind of touching again on the software, it's got that fast queue setup for depth scans and profile scans for all energies and modalities. Conversion of the depth scans to dose and the export of to the PDD tables and to TPR tables. All those various treatment planning systems are included in the system. We don't have, you don't have to go ahead and purchase. So I want to buy I need Eclipse and I need Pinnacle. I don't have to buy them separately. Those are all included with the system. So there's no additional charges there. It's kind of a turnkey system. It includes the everything you need to get up and scanning. And the DMAX forcible pointed DMAX is a nice little feature too, to make sure that you can get a measurement at that point. And for the 1D, you've got that easy single point measurement as well. So that I didn't really touch on that because I kind of was focusing on the 3D today, but the single point measurement gives you the ability to do those TG51 absolute measurements. So I kind of touched on what makes the software easy. It's got the left to right, top to bottom navigation. There's quick queue setup and something I didn't mention, but there's easy copy and editing function. So you can set it up for all your scans for say 6 MB, and you can copy and change those to 10 MB as well. So you've got not only 6 MB but 10 MB. So it's a quick editing function. No hidden features. Everything's right at your fingertips. You can choose your step or continuous scanning with those multiple zones as well for the different resolutions. I mentioned the full export to the treatment planning systems and different formats. Import functionality for the legacy scan data from older scan systems as you see fit. And again, very straightforward post scan processing and metrics available at your fingertips as well. So kind of mentioned real quick too, the now available in version 3.1. We're actually on the cusp of releasing 3.2 as well, but that and 3.1 added scan comparison, not only the gamma analysis, but that direct comparison back to a user selected set of reference scans for seeing those metrics comparatively, and then that export to CyberKnife as well. But that's kind of all I had today. I just like I said, it was just a quick overview of the Water Phantom and its kind of functionality.